This is the second part for Lesson 7.3, Systems of Nonlinear Equations. In the previous video, we talked about the different ways you learned how to solve linear equations, and we are going to use two of those methods to solve systems of nonlinear equations. We're going to first solve them algebraically, and so algebraically we're going to be using the method of substitution to do this. Okay, so remember that with substitution, you have to have one of your equations to say either x equals or y equals to be solved for one of the variables. So if you look at your first equation, y is the same thing as 2x plus 1. So if y is the same thing as 2x plus 1, that means that I could put 2x plus 1 right in that second equation for y. So I'm going to rewrite my second equation, x squared plus, instead of y, I'm going to write what y is equal to. And now what I have is I have an equation with only one variable, and I can solve that. So x squared plus 2x plus 1 equals 4. And so to solve an equation like that, it's a quadratic equation, so think about ways you know how to solve it. So what you could do is you could move your 4 to the other side, and you could factor. If it's factorable, you could move the 4 to the other side and use the quadratic equation, or quadratic formula. One thing I'm noticing though is I'm noticing that this is a perfect square. So what I could do is I could write that as a perfect square, and I can take the square root of both sides to solve it. So I'm going to do that just because I think that that's the fastest way. So I'm going to have x plus 1 is equal to, remember I put the radical there, so I'm going to have to say plus or minus 2. So that means that x is equal to negative 1 plus 2 and negative 1 minus 2. And so negative 1 plus 2 is 1, negative 1 minus 2 is negative 3. So I have two solutions. My two solutions mean I'm going to have two ordered pairs. In the first ordered pair, my x is going to be 1, and in the second ordered pair, it's going to be negative 3. Now, of course, it doesn't matter if you put negative 3 in the first ordered pair. That's just the order I got them in. So now what I need to do is I need to now find out what y is. So I'm going to take the x's, and I'm going to one at a time put them in place of x in one of the equations. So the first one seems the easiest one. So I'm going to say y is equal to 2 times 1 plus 1. So 2 times 1 is 2, plus 1 is 3, so 1, 3 is one of my solutions. Then I'm going to take negative 3 and put it in. So 2 times negative 3 is negative 6 plus 1, which is negative 5. So negative 5 is my other one. So what this means is it means that if I was to solve this equation, or this system of equations, the two ordered pairs 1, 3 and negative 3, negative 5 would both satisfy or make true my system. Now we'll talk about that a little bit more in just a second. What we're going to do next is we're going to solve by graphing. So we're going to graph both of those equations that I have right up here in number 6, and we're going to see, do they intersect at 1, 3 and negative 3, 5, negative 5. So the first one is a line, y equals 2x plus 1. So I'm going to graph that. So starting at 1, my slope is 2. Now remember that when you're solving by graphing, accuracy is super important, so you want to make sure that you get enough points there. You want to get a straight edge and make sure you've got a nice straight line because you can't afford to have something that's a little bit off. Now for my second equation, that's a parabola. X squared plus y equals 4. But I can't graph it like that. So if I have x squared plus y equals 4, I need to make that look like something I know how to graph. So y equals negative x squared plus 4. That's the parent function of a quadratic reflected and moved up 4. So I'm going to take my parent function, I'm going to move the vertex up 4. It's going to be reflected with no stretch. And so I know how to graph my parent function. And so if I go over 3 and then down 9, and then don't forget to use the symmetry. So graphing my parabola, that's what I have. So then my solution is going to be that point right there and that point right there. And so this first point, that's 1, 3, and this ordered pair down here is negative 3, negative 5. And if you look, that's what I had before. So I found those numbers algebraically. I've also found them graphically. Now to verify, that means plug in. So I'm going to take my system and I'm going to plug in one at a time each of the ordered pairs. So I'm going to pause the video and write down the system, and you do that too on your notes. You're going to rewrite the system, and then we're going to plug in and make sure. Okay, first thing I'm going to do is plug in the point 1, 3 into my system. So remember that x is 1, y is 3. So I'm going to put in y is 3 equals 2 times x plus 1. Is 3 equal to 2 times 1 plus 1? Yes, that is true. For the next one, I'm going to put in x squared, so that's 1 squared plus 3. Is that equal to 4? That is also true. So I know that that's a correct solution of my system. The next one I'm going to do is I'm going to do the ordered pair -3, -5. So again, I'm going to start with the first equation and say y is equal to 2 times -3 plus 1. Is that true? So 2 times -3 is -6 plus 1 is -5, so that's true. And then I'm going to say x squared, so that's -3 squared. Remember, you have to square the whole thing, so that's going to be positive. So positive 9 plus y, so plus -5. 9 minus 5, is that equal to 4? Yes. So I have verified algebraically that both of my solutions are correct. I have shown graphically that those are the solutions, and I have solved using substitution. Now, for every system of nonlinear, you don't have to do all three ways. You don't have to do all three things. You should do either the first or the second, the substitution or the graphing at least, and you definitely should be verifying to make sure that your solutions are true. Especially on a quiz or a test, you need to verify and make sure that you're really putting down the right solutions. Okay, let's go to number 7. So we're going to do the same thing. So I want you to pause the video, and I want you to make an attempt, an honest attempt at trying to do this yourself, and at least doing either the substitution or the graphing on your own, and then come back and we'll go through all of it. Okay, algebraically, I need to take one of my equations and make it say either x equals or y equals. So the top equation, it would be easiest to say y equals x plus 4. So I just moved the x to the other side. So now I'm going to take that and I'm going to put it into the other equation in place of y. So I'm going to have x squared plus, and then instead of y, I'm going to have x plus 4, quantity squared equals 16. So we've talked about this a lot, how you need to make sure you don't say x squared plus 16 right here. It's x squared plus 8x plus 16 equals 16. So I'm going to have 2x squared plus 8x, and then if you move the 16 to the other side, you have 0, so equals 0. Now you can do a couple of things here. You can divide everything by 2. That's perfectly fine. You cannot divide everything by x, because if x is 0, you can't do that. So you never, never divide by x. So what I'm going to do instead is I'm just going to solve this by factoring, and I'm going to take out a GCF, which is 2x. And I'll be left with x plus 4 equals 0. And so solving with a zero product property, that means that either 2x is equal to 0 or x plus 4 is equal to 0, which means x is equal to 0 or x is equal to -4. That means that my ordered pairs are going to have x is 0 or x is -4. Now to find the y value for each of my ordered pairs, I'll plug in 0 for x, so 0 plus 4 is 4. Then I'm going to plug in -4 for x, so -4 plus 4 is 0. And so those are my solutions. Okay, remember, if you have a circle and a line, it is possible to have two solutions. Okay, with two lines you can't have two solutions, but if you have like a parabola and a line, you could have two solutions. A circle and a line, you can have two solutions. Now you can also have no solution. If you had a circle and a line that looked like that, that's no solution. You could also have a parabola and a line with no solution. You could have a parabola and a line with one solution that went like just tangent to it, same with a circle. So you can have 0 solutions, you can have one solution, you can have two solutions. Depending on the shape, you might even have more. Like what if you had a circle with an absolute value? Whoops, depending on how you draw that, you could even have up to 4 solutions there. So if I had 1, 2, 3, and 4. So depending on the type of equation you're looking at, you could have multiple solutions. So that's why it's really important to understand what the graphs look like. Okay, I'm going to go ahead and graph these both graphically. So the first one is the equation, and I already wrote it as a line y equals x plus 4. And so I'm going to graph that one. And then the second one is a circle, center 0, 0, radius of 4. And so graphing that one, so I see I have two solutions, right there and right there. And looking at those numbers, this one is 0, 4, and this one is negative 4, 0. So what I did algebraically matches what I did graphically. So I'm pretty confident that when I verify this, it's all going to work out really nicely. So when I verify, I'm going to first write down my equation. So negative x plus y equals 4, and x squared plus y squared equals 16. And I'm going to try my first point. So 0, 4. So negative 0 plus 4 equals 4, check. And 0 squared plus 4 squared equals 16, check. So that is true. Then I'm going to try my second point, negative 4, 0. So negative 4 plus 0 equals 4, true. And then negative 4 squared, that's negative 4 times negative 4 is 16, plus 0 squared equals 16. That's true. So both of my solutions I have verified algebraically. Okay, going to number 8, again, I want you to try this yourself. Notice that you have a linear equation and you have a parabola, a quadratic equation. So you can think about what the picture would look like, and I want you to try this algebraically and see what you can find. Can you do this yourself? If you cannot do it yourself, then that's where you need to be a little bit concerned at this point that you're not understanding, so you might need to come and ask some questions. So go ahead and pause the video and see if you can get some of this done yourself. The first thing I'm going to do is take that first equation and divide everything by 3. So I have x plus y equals 1. And then I'm going to put it into a y equals so that I can substitute. So I'm going to have y equals negative x plus 1. The next thing I'm going to do is I'm going to put this in for y in my second equation. So I'm going to have negative x plus 1 equals x plus 2 quantity squared minus 3. So now I need to expand that out. So negative x plus 1 equals x plus 2 quantity squared is not x squared plus 4, it's x squared plus 4x plus 4 minus 3. I need to get everything on one side because to solve a quadratic equation, that's what I need to do. So I'm going to add x to both sides, and I'm going to subtract 1 from both sides. So I'm going to have 0 equals x squared plus 5x, and then 4 minus 3 is 1, minus 1 is 0. So then to solve that equation, that's going to be something I'm going to factor out of GCF. That's going to mean x is equal to 0 or x is equal to negative 5. So my two ordered pairs are going to be x is 0 or x is negative 5. Now to solve and find the second coordinate or the y coordinate, I'm going to put in 0 and I'm going to put in negative 5 one at a time for x right there. So negative 0 is 0 plus 1, and negative 5 is 5 plus 1. So these are my solutions that I got by substituting. And now I'm going to verify that by graphing. So my first equation is a line, so I've got that negative x plus 1. My second equation is a parabola with a vertex at negative 2, negative 3. So I'm going to graph that. There's no stretch, no reflection. So I'm going to go over 1, up 1, over 2, up 4. And I see I've got one of my intersections right there, but I need to go a little further and get the other one. So I'm going to go over 3, up 9, there it is. Okay, so it looks like my intersections are at 0, 1, and then this one right here is at negative 5, positive 6. And if I look, that's what I had for my solution. So I've seen that graphically and by substitution. Now to verify it, I'm going to come down here and just put it in my equations. Now when you do this on a test or a quiz, you don't have to necessarily write it all down and show me everything, but you should not be turning in your test or quiz if you haven't verified your solutions and made sure that they work, because that wouldn't make any sense. So the first one I'll do is 0, 1, so I'm going to have 3 times 0 plus 3 times 1 equals 3, true. Y equals 0 plus 2 squared, which is 4, minus 3, which is 1, true. The next one, negative 5, positive 6. I'm going to have 3 times negative 5 plus 3 times 6. Is that equal to 3? Yes. The second one, 6, equals negative 5 plus 2 is negative 3 squared. That's 9 minus 3, which is 6. So I verified it using algebra. Okay, for the next 3, we're not going to do all of that necessarily. We're just going to solve graphically and write the solution as ordered pairs. So my solutions will be like 2, maybe 3. It could be no solution, just depending. But if we remember how to graph absolute value, and you know a lot about transformations now, so remember that the parent function for absolute value is like that. And so this tells me there's a reflection and a stretch, and then this tells me it's going to be moved up 2. So what I'm going to do is I'm going to graph that. So I'm going to take my vertex and go up 2. Instead of going over 1, up 1, I'm going to go over 1, up 2 because there's a stretch. Oh, and I have to go down, actually not up, because there's a reflection. So there's also symmetry. So instead of going over 2, down 2, I'm going to go down 4. So basically you're looking at a slope of negative 2 and positive 2 depending on which side of the graph you're on. And so just get this graphed. You can pause the video and get yours graphed. And if you want to pause the video and get the other part of it graphed and see if you can come up with the ordered pairs, and then come back on here and check and make sure that you did it right. Okay, you should have graphed the second one as a parabola. It's going to be no stretch, no reflection, move down 1. So the parent function will be at 0, negative 1 for a vertex. It is going to have no stretch, so it's going to go over 1, up 1, like that. And so I can see that my solutions are right there. So it's going to be at 1, 0, and negative 1, 0. Now, if this were a test or a quiz, before I turned this in, I would check to make sure that both of those ordered pairs work. So we would want to say negative 2 times the absolute value of 1 plus 2, is that equal to 0? And if it's not, then I did something wrong. Then y equals 1 squared minus 1, that's true. So I've checked the first one. For the second one, negative 2 times the absolute value of negative 1. So the absolute value of negative 1 is 1, so negative 2 times 1 is negative 2, plus 2 is equal to 0, which is what y is supposed to be equal to. Plug it in the other one, make sure it's true. But please, please do not do your quiz or test without verifying your solutions. Okay, number 10, go ahead and pause the video. You do have a line and an absolute value graph again, so go ahead and graph both of those and find the solution, then come back here and make sure you've got it. Okay, your graph should have looked like this. The purple is my line, and the green is my absolute value. And so when I look for my intersection, I see 1, 2, and so my points are 2, 2, and then negative 6, negative 2. And so then I would verify that before turning in a quiz or a test, which I have done, but anyway, that's what you should have. Okay, for the last question again, please pause the video, graph both of those, and come up with your ordered pairs. Okay, if you did this right, you graphed your parabola and your line. And I see that I have 2 points where they intersect. And so my ordered pairs are negative 2, positive 5, and 3, 0. Again, before a quiz or a test, if you are submitting that, you want to make sure that you've checked that to make sure that it's right. Okay, that concludes the lesson for 7.3. You should now be able to do the assignment. And then once you submit it, you'll do the quiz.